Hello. Today we're going to be doing lesson number 2, polynomials multiplying, lesson 1. Okay, and this is found on page number 1 of your notes. So here we go. Before we can do this lesson, we're going to do a little review of exponents and how to multiply numbers that have exponents and variables, numbers and variables that have exponents. Okay. So basically, just a short review of exponents. The big number is called the base. The little number is called the exponent. Okay? The exponent is the number of times that the base is multiplied by itself. So if I have 5 to the third power, this would be 5 times 5 times 5, written 3 times because it's 5 to the third. And 5 times 5 is 25, times 5 is 125. So let's evaluate the following expressions here. Okay, let's say I have 2 to the third power. So basically, on the side of my paper, I do 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 to the first power will be just 3. 3 to the 0 power is 1. Any number raised to the 0 power is 1. Then I have negative 3 to the second power. Okay, now notice that the exponent 2 is only going to apply to the base 3, not to the negative. Okay, so basically I'm going to have negative and then 3 times 3, so this would be negative 9. Okay. Now, if I have a parenthesis, then yes, the exponent applies to the negative sign. So basically, I'll be doing negative 3 times negative 3. Negative times a negative is a positive, and 3 times 3 is 9. So the answer here is 9. Okay. Then I have negative 3 to the third power. So negative 3 well, let's do the signs first. Negative times a negative is a positive. Positive times a negative is a negative. 3 times 3 is 9. 9 times 3 is 27. So that means that this would be negative 27. Now, mathematicians, after they looked at these types of problems and did many more, they came up with a pattern or a rule for whenever you have a negative number raised to a power. And so we're going to go down here, and here's the rule. The negative sign rule is if a negative number is raised to an even power, just like example letter E, I have a negative number raised to an even power, then, and sorry for the typo, please add the word the, then the negative sign disappears. If you notice right here, I have a negative number raised to an even power. What happens to the negative sign? It disappears. The rule then says if a negative number is raised to an odd power, then the negative sign stays. So if you notice, I have negative 3 to the third power. What happens to the negative? This is an odd power. The negative stays. Alright? The negative sign rule is only applied if and only if the sign is inside the parentheses. If you remember letter D, the negative is not inside the parentheses, so even though this is an even power, the negative stays. This rule only applies if the negative is inside a parenthesis. So let's give it a try. Suppose that I do letter G. Here I have a negative 3 raised to the fourth power. Question is, will the negative stay or disappear? Well, because this is an even power, the negative disappears. And then, what is 3 times 3 times 3 times 3? 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So this would be positive 81. Okay? Alright, the next one. Negative 3 to the fifth power. 5 is an odd power. So that means the negative will stay. And then 3 to the fifth power, Let's go ahead and erase this here for a second. And 3 to the 5th power, you would add another 3 here. So 9 times 9 is 81. And 81 times 3 will give you 243. Okay? Alright. Now with that being said, I want you to stop the video and try the practice problem 2.1. Okay? Whenever you finish trying these problems, go ahead and restart the video and let's check the answers. Okay, welcome back. You have tried practice problems 2.1, so let's go over the answers. 7 to the 0 power is 1, because any number raised to the 0 power is 1. Negative 8 to the 2nd power, will the negative stay or disappear? The negative will disappear. Yes, the negative will disappear because this is an even power. So this would be positive 64. Over here I have a negative raised to an even power. This one, the negative will stay because there's no parentheses, and 8 to the 2nd power is 64. Okay, next one is 123 raised to the 0 power, so that would be 1, because any number raised to the 0 power is 1. And the next one is 13,253 raised to the 1st power. Any number raised to the 1st power is the same number, so this would be 13,253. And that's practice. These are the practice problems. All right, let's do example 2.2. Evaluate each expression for x equals negative 2. So basically what you're going to do is you're going to substitute. Instead of writing x, we're going to put negative 2. So this would be 4 times negative 2 to the 3rd power. Please remember that when you substitute, you must put parentheses. Alright, so now I have a choice. What should I do? Multiply or use the exponents first? Well, if you remember order of operation tells us to do exponents first. So let's go ahead and do the exponents. So copy the 4. And question is, will the negative stay or disappear? Because this is a odd power, that means the negative stays. And 2 to the 3rd power is 8. Now what's 4 times negative 8? That will be negative 32. And that's the answer for this problem. Let's go ahead and do the next one. Then I'm going to have 12. Instead of x, I'm going to plug it in negative 2 to the 2nd power. And then this will be 12 over negative 2 to the 2nd power. Will the negative stays or disappear? Well, because this is even, the negative will disappear. 2 to the 2nd power is 4. And then 12 divided by 4 is 3. Okay, again, stop the video, try these practice problems, and when you finish, restart the video so you can see if you got the right answer or not. So go ahead and stop the video now. Okay, welcome back. Let's see what you got for the practice problem 2.2. Basically, you're going to substitute. So let's put parentheses. Remember, anytime you substitute, put parentheses. Next, order of operation tells us to do exponents. So a negative 3, will the negative stay or disappear? Well, because this is even, the negative will disappear. So we're going to get 5. And then 3 to the 4th power will be 81. So if you notice, the negative disappear. 5 times 81 is 405. And that's the answer for this problem. Let's do the next one. Next one will be 6 over Put parentheses, negative 3 to the second power. We have division and exponents. Order of operation tells us to do exponents first. So will the negative stay or disappear? Well, this is even, so the negative disappears. And 3 to the second power is 9. Okay, now let's do the division. Can I divide 6 by 9? And the answer is no. Meaning, can I divide 6 by 9 and get whole numbers? No. So let's go ahead and try to reduce it. Basically, you ask yourself, what number divides 6 and 9? Or you can ask, what number goes into 6 and 9? And the answer is the number 3 goes into both 6 and 9. So that means we're going to divide 6 divided by 3 is 2. 9 divided by 3 is 3. So that means the fraction reduced to 2/3. Okay? Very well. Now let's go ahead and proceed to the next example. Next example is going to be 2.3. And it says to simplify and write in exponent form. But before we do the example, I need to tell you about this property. The property is, if I multiply two numbers of the same base, that means I can add the exponents. So let's take a look over here. Here I have two numbers that I'm multiplying, and do they have the same base? Base is the big number, and yes, they have the same base. So what can I do with the exponents? I can add them. Okay, you might ask, how is that so? Well, basically, what's happening behind the pictures is the following. I have 2 to the third power, 2 to the 7. 2 to the third power is 2 times 2 times 2. And then 2 to the 7th power is 2 times 2 times 2 times 2 times 2 times 2, whoops, times 2 times 2. So 1, 2, 3, 4, 5, 6, 7. So 2 to the third is these guys, 2 to the 7 is this guys. When I multiply together, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in other words, instead of writing all those out and counting, mathematicians have saw that I can take a shortcut and just add these numbers. So 3 plus 7 is 10. So that's how they came up with this rule. Okay? So let's go ahead and do the next problem. And by the way, we can leave the answer like this because the problem told us to write in exponent form. Okay? Alright, very well. Let's go to letter B. Can I add these two exponents? So please be careful. To be able to add the exponents, the bases have to be the same. In this case, 3 and 2 are not the same. I cannot add these two exponents. But I can add 2 and 7 because they have the same base. So what I'm going to do for my answer, I'm going to write 2 to the third because there's nothing I can do with this guy. But the 3, this would be 3 to the 9th. And that would be my simplest form in exponent form. Alright, let's go to the next one. Next one, I see base 2. And I also see base x. You know, base could be a number or a letter. Alright, base 2. The exponent here is 2. This 2 does not have an exponent. So what I'm going to do is, I'm going to put a 1 there. Okay, you don't have to, but just to illustrate, if a number does not have an exponent, there's an invisible 1. Okay, same thing here with the x. X does not have an exponent, so I'm going to put a 1 there because there's an invisible 1 there. We just cannot see it. Okay? Now that I have that, let's do 2 to the second times 2 to the first. 2 plus 1 is 3. And 3 plus 0 is 3. So this would be 2 to the third power. How about the x's? Let's do the x's now. X to the third times x to the 7. 3 plus 7 is 10. 10 plus 1 is 11. Very well. Let's continue with letter D. I have the same basis, So what can I do with the exponents? I can add them. My base is negative 3. And my exponents, 2 plus 3 is 5. 5 plus 7 will be 12. Now there's more that I can do to simplify this, because I know the rules of the negative sign there. The negative sign rule, remember? If I have a negative number raised to an even power, the negative sign disappears. So that means I can rewrite this as 3 to the 12, and I don't have to have the parentheses anymore. Alright, let's go to letter E. They have the same basis, so my answer is going to be negative 2, and 3 plus 8 is 11. Now, we can apply the negative sign rule. Have a negative number raised to an odd power, so that means the negative stays, and this will be 2 to the 11th power. Very well. The next one. Remember, this is an invisible 1, invisible 1. Okay? Can I add these two exponents? The answer is no, because the bases are different. Okay? So basically I'm going to have 2 times 5. And by the way, a negative times a positive is a negative. But with the x's, I can add the exponents. So the x to the 3 plus 2 is 5. Alright. The next one. Have the same basis. So this would be 2 to the 8th. The x is going to be x to the 2 plus the invisible 1 is 3. And then the y is going to be y to the 7. Okay? So this concludes the examples for example 2.3. Now, go ahead and stop the video and try practice problems 2.3. So stop the video right now. Okay, welcome back. Let's go over the practice problems 2.3. They have the same basis. This will be negative 7. I'm going to add the exponents, so it will be 14. And apply the negative sign rule. Because I have an even exponent, the negative disappears. So this will be 7 to the 14th power. Next one. I have the same basis, so it will be negative 5. I'm going to add the exponents. 2 plus 3 is 5. 5 plus 4 is 9. I'm going to apply the negative sign rule. Because this is odd, the negative will stay, and this will be 5 to the 9th. Very well. Let's do the next problem. Remember, there's an invisible 1, so I add the exponents because the bases are the same. So 4 plus 1 is 5. 5 plus 7 is 12. Next problem. I have 3 to the first. 3 to the first becomes 3 to the second. M squared times m to the first becomes m to the third. N to the fifth times n to the sixth becomes n to the 11th. And I have e squared that I put at the end there. Okay? And that's it. Let's do the next one. X to the third times x to the first becomes x to the fourth. Y to the first times y to the fifth is y to the sixth. Z squared times z to the 7 is z9. And that's my answer. And this concludes the practice problems 2.3. Now let's go on to the next examples. The next property it refers to, what if I have a number raised to a power raised to another power? What can I do with these exponents? Basically, what you can do is multiply them. Okay? Also over here, please make this correction. This is supposed to be a B, not an A. Okay? But it's the same, a similar thing to this rule. Basically, if I have two numbers raised to different powers, raised to another power, what you can do is kind of like use distributive property and multiply this times this and this times this. So let's take a look at some actual problems and see how these is applied. Okay, here I have a base raised to a power 3 raised to a power 7. According to the rule, I can multiply the exponents, so this would be 2 to the 21st power. Okay? The reason why that works is because 2 to the 3rd power raised to the 7th power. That means I would have to write 2 to the 3rd power 7 times. So that's 3, that's 4, 5, 6, and that's 7. Whoops. So I wrote this guy that is inside the parentheses 7 times. 1, 2, 3, 4, 5, 6, 7. And if I add these numbers, 3 plus 3 is 6, plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 3 is 18, 18 plus 3 is 21. So that's why this works. Okay, so instead of having to do all this, you can just multiply these two and voila, you got the answer. So let's do the next problem, letter D. D to the 5th raised to the D to the 2nd. 5 times 2 is D to the 10th. Alright. Now let's look at this problem right here. I have I have a couple grouping symbols. I have the parentheses and I have the bracket. Basically what you're going to do is apply this rule. This is an exponent raised to an exponent, so what we're going to do, we're going to multiply these two. So this becomes negative 7d to the 5th. Basically I just copied the sign. And I'm going to multiply that. I'm going to get 6. Okay. Now I'm going to apply this rule here. I'm going to distribute the exponents. Remember that 7 does not have an exponent, so you can always put a 1 there. So let's go ahead and distribute the 6. First of all, I have a negative raised to an even power. That means the negative disappears. 1 times 6 is 6. 5 times 6 is 30. And that's it. The next problem is similar, but I notice this is a 0. And you can, now remember what we said about any number raised to the 0 power is 1. So in other words, everything that is inside this bracket becomes 1. So that one was an actual easy problem there, because anything raised to the 0 power is 1. Alright, let's go ahead and stop the video and try the practice problem. It's supposed to be practice problem 2.4. Forgot to put the 2.4. So go ahead and try these. Okay, so stop the video and try these now. Welcome back. Here are the answers for practice problem 2.4. So let's see how we do. Okay, first thing I'm going to do is distribute the exponents. Okay, so basically I have a negative number raised to an even power, so the negative disappears. And then this would be to the first power, so 4 times 1 is 3 to the 4th. 2 times 4 is m to the 8th. And this would be n to the 12, because I'm multiplying the exponents. If I do the same thing here, remember there's an invisible 1. Well, first of all, the negative will stay because this is an odd power. 7 times 1 is 7, so 5 to the 7th. And 3 times 7 is 21, so p to the 21st power. Alright, very well. If you notice, the negative is outside, so the negative stays. There's an invisible 1. Let's multiply or distribute that exponent. So this would be 2 to the 4th and q to the 20th. Alright, next problem. I'm going to copy the number inside, and we're going to multiply these exponents. So 7 times 3 is 21. Alright, now let's apply this 21 to the inside. So first of all, the negative stays because it's an odd power. There's an invisible 1 here. So 21 times 1 is 21. And 3 times 21 is 63. Alright, let's try the next one. I'm going to copy the inside. 2 times 3 is 6. This is an even power, so the negative disappears. Let's distribute the exponent. So this would be 3 to the 6. And 6 times 0 is 0. And we could leave it like this, or we could remember that x to the 0 is 1. So in other words, 3 to the 6 times 1 is 3 to the 6. So this would be actually the simplest form, so I actually write this as the final answer. Alright, next one. The negative will stay because it's an odd power. The new exponents are going to be, because remember there's an invisible 1, 11 to the 3rd, p to the 3rd. Alright. Put a circle here on our final answers. Alright, very well. Let's do letter G now. The negative will disappear because it's an even power. There's an invisible 1. So when I use the distributive property, this is going to become 3 to the 2nd, x to the 4th, y to the 10th. Alright, next one. What I'm going to do is I'm going to do the first one first, the first parenthesis, and then the second parenthesis, and then at the end I'm going to combine the two. So let's see how we get. I'm going to distribute the 3, so this would be 2 to the 3rd, m to the 15th. And I'm going to do the second one, m to the 4th to the 5th. I'll multiply this, so this would be m to the 20th. And now we're going to add the exponents. It will be 2 to the 3rd, m to the 35th. Alright, next one. The negative will stay because it's an odd power. This will be 3 to the 3rd, x to the 9th, y to the 12th. The next one, the negative will disappear. It will be 2 to the 4th, x to the 8th, y to the 12th. Alright. Last problem. It's going to be similar to letter H. I'm going to get rid of the parentheses first. So the negative goes away. to be 3 to the 4th, x to the 16th, y to the 8th. And then I'm just going to copy the second term there. Now I'm going to combine it. So this would be 3 to the 5th, because there's an invisible 1. So 4 plus 1 is 5. Okay. And then there's nothing else I can do with these, so I'm just going to write down over here. And it's always good practice to write in alphabetical order. So I'm going to write m to the 3rd first, x to the 16th, y to the 8th. And that's my answer. Now, if you wrote, 3 to the 5th, x 16th, y to the 8th, m to the 3rd, it's still correct. I'm just saying that it's always good practice to write in alphabetical order. But if you have all the terms, you're fine. Okay? Okay. Let's go now to the last problem, last example on lesson 2. Suppose that, I don't know if you noticed, but on these problems here, most of the time we did a monomial times a monomial. This time I'm going to do a monomial times a binomial. And the way you do it is you multiply, you kind of like use distributive property. Hold on here. There we go. So we're going to use distributive property excuse me, to distribute the 3x squared to each term inside the parentheses. So I have 3x squared times x cubed is 3x to the 5th. And then I do 3x squared times 4 is 3 times 4 is 12 x to the 2nd. Okay? Now, I cannot combine these two because they have different exponents, so that means my answer is that. Some students, sometimes what they do is they make the following mistake. They write 15x to the 5th. But you cannot do this because this is adding. You cannot add the exponents if you're adding the terms. If you had, for example, 3x to the 5th times 12x to the 2nd, then yes, you can add the exponents. It would be x to the 7th, and 3 times 12 would be 36. So please be very, very careful to distinguish the two. You can add the exponents only when you're multiplying. If you're ever adding and subtracting, to be able to combine these two terms, the exponents have to be the same. Okay? So don't make those mistakes. Okay? Alright, let's do letter B. We're going to use distribution. And this time we're going to multiply a monomial, something that has one term, times a trinomial, 3 terms. 4 times 3 is 12. Remember there's an invisible 1, so c to the 1st times c squared is c to the 3rd. D squared times d to the 1st is d to the 3rd. Then we're going to do 3 times negative 6 is negative 18. C times c is c squared. And d squared times d is d to the 3rd power. Next one. 3 times 14 is 42. C times c is c squared. And d squared times d squared is d to the 4th. And that's my answer for this problem. And I'm sorry, I covered the 4 there, so here is uncovered. So when I did d squared times d squared, I got d to the 4th right there. Alright, go ahead and stop the video and try the next problem. And when you're done, restart the video so you can see the answers. So stop the video now. Okay, welcome back. Let's check the answers for the practice problems. Okay, basically I'm going to use distributive property. And my first term is going to be a times a to the third is a to the fourth, b. Then ab times 3ab squared would be 3a squared b cubed. And the last one would be negative a b to the fourth. And that's my answer. Okay, next one. I'm going to multiply these out. So it would be x squared y times 6y cubed. So this would be 6x squared y to the fourth. And then 6x squared y times y squared. This would be plus x squared y to the fourth. I'm sorry, y to the third. And the next one would be x squared y times negative 28. So 1 times negative 28 is negative 28. X squared times nothing is x squared. Y times y is y squared. And the last one would be x squared y times 36. It would be positive 36 x squared y. And that's my answer. Alright, very well. This concludes lesson number 2. Okay, so now go ahead and you can do the assignments. Okay, and once you do the assignments, you can check with the answer key to see if you did it correctly. Thank you very much for your time, and have a great day.